So my name's Sarah Breen Lovett. I'm the Engagement and Education Leader at Building 4.0 CRC. And we really enjoyed this demonstration session because it's great to get hands-on close contact with what's happening in the field and get some experts come and show us demonstrations. So please follow them up and go to their stand following their spiel here they will give you. The first demonstration that we have today is from our new partners, Verton. Marcio Casagranda, Head of Business Development at Verton Australia, will demonstrate Verton's remote control solution to orientate suspended loads from a safe distance. No doubt you've seen the video. It's already reeling over there, and we've been playing it on the big screen as well. This is a really innovative way to move loads around the site that increases the safety and precision. This equipment allows lifting operations to be hands-free, removing operators from the line of fire and completely changing the risk profile of lifting operations. So we welcome Marcio to the stage now.
Thank you, Sarah. Thank you for inviting me. So as Sarah presented, my name is Marcio Casagranda. I'm with Verton Australia. And what we're trying to do is to bring a little bit of innovation, technology, and the first step into automation into the construction industry. Specifically with, can you hear me now? Okay, thank you. Specifically with cranes. And in a very simple way, what a crane does is pick something up from point A, move it and drop at point B. One of the biggest challenges with crane operations is maintaining control of the suspended load while it's up in the air. And what we do today is this. A couple of people come very close to the load and physically touch it to push it, or grab a tag line to pull it, to orientate before it's dropped into position. What that means is that we have 3 or 4 people very close to a suspended load. And that's where most of the serious accidents and fatalities actually happen. And that's where we come in. That's where we can help this situation. At Verton, we developed this equipment that orientates suspended loads using a remote control. So instead of having 3 or 4 people pushing or grabbing tag lines, you need one person up to 100 meters away that can do that from a safe distance. Our product range, we have 2 main products. So the smaller unit, what we call the SpinPod 7.5, and it can orientate up to 25 ton. The design is modular, so we can bring 2 units together, doubling that capacity. The bigger unit, which is the one on the right, is what we call the SpinPod 30. And as one unit, it can orientate up to 100 ton. And again, it's modular, so we can put 2 of them together. One additional flexibility of this technology is that we can actually incorporate into existing tools. So the picture at the bottom is actually a lifting tool that was designed and developed in partnership with a Dutch company that manufactures and installs wind turbines. We are also working with another partner to do a pipe handling tool for offshore installations. In construction in particular, it makes sense to use this type of technology in busy inner city projects where you have repetitive lifts, anywhere where there are tight space, where precision is required, for example, on the installation of prefab. So all of those is where you get the best return on investment with this equipment, as well as the safety aspect, which is wherever there is a crane and you have a Verton unit, there is no need for anybody to be near the load. And here we have some results of projects that we already work with. So the picture in the middle shows one shutdown we did with a mining company in WA. They did that shutdown to replace 35 of those transformers. And they plan to do that in 8 days using traditional methods with tag lines. As soon as the Verton unit was brought to site and they started using it, they finished that shutdown in 5 days, 3 days ahead of schedule. The picture on the right is a construction project we worked with in New Zealand, where they had to install these precast concrete planks through the structure of the building. and they had 3 or 4 people in different levels of the structure, pushing and guiding that plank through the skeleton of the building. And they were doing 16 lifts per day. As soon as we brought the Verton unit to site, they jumped from 16 to 26 lifts per day. And instead of having 3 or 4 people hanging out from the building, they had just 1 person down on the floor. And the last one is the infrastructure project we are working with in Brisbane. Is the Cross River Rail project. And they have that unit on site for more than 2 years now. They used to dig 350 tons of soil using conventional methods before bringing the unit to site, and they jump to 1,700 tons every 24 hours. So the major benefits is safety, efficiency, and the ability to do the same job with with a smaller crew. Please come and see me afterwards. I'll show you the virtual tool and answer any questions you might have. Thank you.
Thank you, Marcio. That was fantastic. And you can have a go of the virtual crane demonstration on that side of the room in the next break. The next presenter is Dr. Ali Rashidi, researcher with the Future Building Initiative at Monash University. And his student, Yi Si Lee, will be presenting an AR/VR game which aids in workforce training. This helped build the framework for the project 12 AR/VR technologies in vocational education and training as a scoping study. So after that, you can also speak to Ali about that project, where they examine the most significant factors to determine the appropriate technology for specific skill training in the construction industry. Welcome, Ali, to the stage. Thank you.
Good afternoon, everyone. Thanks, Sarah, for inviting me. Just playing the video here. I'm part of the digital project management team coordinator and in the Building 4.0 CRC. And then we tried to design and then doing some study on the VR, AR technologies for vocational education and training. And then basically we are looking for extended reality technologies. And these applications is multidisciplinary platforms in a game-based VR that we are trying to bring in the different disciplines, mechanical, electrical, piping, and industrialized building system, specifically looking at the lighter steel framing system and some project management aspects to train those who are really interested to come into the industry. And these platforms can be extended to other platforms like augmented reality and mixed reality. And this short demo that we are trying to show here, we have a real-time capturing all the activities of the trainees and then reporting to the supervisor. So basically, the current practice that we are trying to just bring it into the virtual environment to just, the new technology of the building is quite, in terms of training, quite dangerous, difficult, and somehow dirty because we have to go to the construction site. But we try to just simulating everything in a virtual environment and putting some gamification and game elements into that. So without any knowledge of construction, you can play around, train, and then getting into the construction site immediately. So feel free to try our short demo. We try to squeezing the game and the VR training into very short demo for today. If you're really interested, please get in touch with us and try our VR game and go through that one. It's kind of like a game environment. It's not very serious training scenario. So, but behind that, we have a lot of learning outcomes. We try to just train the practitioners how to become the building inspector. And then that's why this disciplinary platforms is going to be helpful to the supervisor of the construction. So feel free, try it over there. My student is ready to help you to try the VR demo. Thank you.
Thank you very much, Ali. We're really pleased that we managed to get the headsets and everything here today. So please have a go of that. Our next presenter from the University of Melbourne is Dr. Tu Lee. Tu is a research fellow in the Department of Infrastructure Engineering, and he will present Project 42, Workflow Automation Tools for Residential Home Designs. This scoping study outlined the challenges in the design process of a residential house from a volume house builder perspective, including the short duration of the design phase and the high number of human errors that occur in the current workflow. Please welcome Tu to the stage.
Hi everyone, and thanks Sarah for very kind word. I hope you all have a good time today with the showcase. So this is the demo for the Project 42 Workflow Automation Tools for Residential Home Design. This project aims to solve the biggest challenge brought to us by our industry partner, Bentley Home and M-Modular, is that there is currently no interoperability between the software during the design phase in the design process within the volume builder. And to begin with, the workflow adopt a BIM platform and an embedded programming language to automate the task. And for this case study, we use Autodesk Revit and Dynamo as an example, but obviously the proposed workflow can be used with any other BIM and embedded programming language. And considering the fact that there is a limited number of design templates that a volume builder can use to build house for their customer, the new workflow utilize the template at the starting point. So so as you can see, it is an example of a design template. The design template comprises three parts: the Revit template model, the Dynamo code file, and the input file. So the request from customer will be stored in a spreadsheet for this case, and all of the information will be stored in a spreadsheet. So a sales representative with no knowledge on BIM modeling can use and interact with their customer. And the template model then will be updated based on the input parameter from the spreadsheet to create the final model comprising all of the necessary detail, including the 3D model, the drawings, and build qualities. So and all of these tasks are automated using a subroutine programmed by the visual programming language in Dynamo. So as a result, all of the tasks are automated, including editing drawings, measuring qualities, as well as updating change. So this is the structure of the workflow that we are proposing. And now I will show you how the workflow works. And in this example, modification to the BIM model can be made directly from a spreadsheet. And the update to the BIM model can be done automatically or manually by pressing the run button in the Dynamo code in the back end. So afterward, as you can see here, the model will be created. The final model will be created, comprising of the final 3D model, the drawings, and build qualities. Moreover, like for example, we are changing the openings from the spreadsheet, but this input file can be extended to incorporate more parameters such as materials, feature and fixing, and all of the door and opening options. Finally, the data after being manipulated can be exported to a CSV file, and this CSV file can be transferred directly to a cost estimation software such as DataView. As a result, the workflow automatically automate all the tasks, including adjusting the drawing, exporting the drawing and the quality in a usable format that can be used in another cost estimation software. So it can be noted that these build qualities is set up with rules and exceptions, and therefore it can be exported directly to a cost estimation software without using any any further data processing. So that is the demo for today. Thanks for your own attention, and I'm happy to discuss more about it with my over there. Thank you.
Thank you so much too. That was fantastic. What a very intricate and detailed process that you laid out there. It's really great. And if you'd like more information too, it's just based over here in the corner afterwards in the mixing chamber session. Our last demonstrator is one of our project leads across a few projects, Dr. Phil Christopher. He's a research fellow in the infrastructure engineering faculty at the University of Melbourne. He'll be presenting project 45, which is a prefabricated wall integrated system, phase 2 demonstration house and market study. This project aims to bring the concept of a high performance prefabricated wall system to the Australian home market, with the goal of delivering both 7-star and 8-star NatHERS. Welcome Phil to the stage, please.
Thank you, Sarah, and thank you everyone for your attendance. So today I'm presenting on what Chris would say is a bricks and mortar project. Just we've removed both the bricks and the mortar from it. But yeah, this is really a project whereby we're going to actually start to build some of the outcomes from the first phase project, Project 8, with our industry partners, Bentley Homes and Ultimate Windows. Unfortunately, I don't have the physical prototype here today because we've just started that process, but I'll run you through what we're going to build and what the benefits of that are today. Okay, so what we set out to do was design both a 7 and an 8-star home. 7-star, obviously, new minimum compliance for a home, and the 8-star one for a higher efficiency option for our buyers. As part of that, we really wanted to develop better methods of building that wall system in a factory, bringing it out to site. We're going to trial that through real construction. We're going to start off with a smaller scale project and scale it up to larger homes throughout the duration of this project. And once we've done that and understood a bit better about what worked, what didn't, and refined the system, we really want to then better understand what's driving buyers to then choose this type system and really quantify and explain the benefits to the market from such a system. So the home itself, we started off with something people actually wanted to buy, not a prefabricated unit that looked, I guess, too generic. We've worked closely with Bentley Homes on this design. Our current design achieves 7.3 stars, up from the 6.6 the brick veneer would achieve, with very little other extravagant energy upgrades. So we haven't got like really highly spec'd windows or massive amounts of ceiling insulation. It's relatively standard in its design. So to achieve that performance, we're really quite happy with. We will be upgrading to an 8-star option as well with those higher spec'd energy outcomes. And it does achieve 8-star in Sydney and Perth, which is easier to do than Melbourne, as many of you will be aware. Now, the wall system itself, we set out to not solve every problem in the prefab industry, but really pare it back and achieve something that would be readily accepted by the Australian market. So we haven't gone on these outrageous dimensions or difficult to construct systems, and we've gone for simplicity of fabrication, the ability to install electrical and mechanical systems on site, which is obviously a pain point for a lot of integrated panelized systems. We've also gone with, sorry, it's going forward a slide on me, cladding flexibility. So clients may prefer lightweight versus heavyweight cladding. So really enabling clients or buyers to select what they want on their homes. And as I've mentioned, the internal fit out on site. So it's a basic fly through. It's a hard act to follow on to previous presentations, but we'll give a fly through the wall system as it is. And explain a little bit about it as we go. So here. Okay, great. So here we can see our standard wall system. External, in this example's weatherboard in blue, and on the internal side, we've got plasterboard. Our typical panel's 2700 high, so standard wall height. and 3 meters across for a standard width. We will be able to obviously vary that width depending on our home. Now, I'm going to pause it there for just a moment. From our weatherboard, as we move in, you'll see a number of different layers of the system. The first layer, we've got just not a 70 by 35 timber studs. And what that achieves is really easy fabrication, no special screws, no advanced systems, just typical construction methods, still done in a factory at this stage for this layer. And we'll keep moving our way around the wall. On the inside here, we have plasterboard, again, with our 70 by 35 studs. Now, here's the key point. Those 2 attributes of the system will be done on site to ensure that we're achieving a nice, straight, vertical quality system that's been installed correctly without relying on everything being done in a factory and then maybe on-site conditions not being quite right. For example, a not quite level concrete slab. We'll keep going through here. So as we move around our wall, we've got typical spacing between our studs and our noggins again, so that your mechanical, your electrical, your plumbers, everyone's used to working with those spacings, those materials. You don't need special power points or special adapters in order to get your installation to work and to be compliant. Now, coming to shortly to what makes the wall the more energy efficient wall is the fact that we now have a continuous sheath of XPS insulation on the outside of the wall. So that's the one we've just removed now. Now that continuous sheath of insulation, I guess, gets around thermal bridging, and you might say it's a timber system. We don't have to worry about thermal bridging. Well, timber does thermally bridge, not as much as steel, obviously, but still quite significantly. So enabling that continuous sheath of XPS really improves the performance of our system considerably, not reflected in the standards and codes, but we are getting a really high performance home by enabling that that continuous sheath of insulation. And now we've paired it back to our basic frame. So nothing in its own groundbreaking, but the integration of this system to enable it to go into the Australian market, we think is at the right point of prefabrication. And we'll be putting these together over the coming weeks and months and hopefully have something to show you at the next CRC event. Thank you.
Thank you so much, Phil. It's great to see the detail of that coming together, and I can't wait. Hopefully, as Phil said, we may have a prototype for the showcase, which at the moment scheduled for the 13th of September in March, so small plug there. And let's enjoy a little bit more lunch. We've got half an hour now where you can get around and speak to any of the demonstrators, indeed any of the project leads or PhD students that are here. For half an hour, we'll have a bit more of a break, and then we'll come back in here for the next sit down session. Thank you very much.